Assalamualaikum warahmatullahi wabarakatuh. My name is International Fitri binti Umar Yunus. My student ID 2019244018. So today I will explain about the lab sheet 3, which is the impact object. So we go to the objective. The objective of this lab is to measure the reaction force produced by the impact of a jet of water onto various target plane surface. And next objective is to investigate and determine the force required to keep a target at a datum level while it is subjected to the impact of a water jet. And lastly is to compare and analyze the experimental result with the theoretical calculated values. So this is the apparatus. First one, this is the pointer, and this is the spring tension adjuster. And as you can see, here is wing nut, and it has two. And this is the interchangeable target. This is the brass weight, and at the top is the weight carrier, and this is the weight platform. And as you can see, this is a spring, and behind and at the wing nut it has also the screw nut, and this is the interchangeable nozzle, and at the behind it has a water inlet. Okay, this is the target that we want to use of this experiment. Okay, we proceed for the procedure. So let's see how the experiment will be conducted. So firstly, you have to open the weight platform. So this is the weight platform. So you have to open it by unscrewing the screw nut and the wing nut. So here it has the screw nut and the wing nut. And after that, you have to take the platform from the setup. And then for the next step is you have to attach the 5 nozzle onto the bottom vertical shaft, and have its weaving on 2 top vertical shafts. So firstly you have to take this nozzle, and you have to put the nozzle at here like this, and after that you have to tighten it. The hemisphere target. After that you close the weight platform like this, and by unscrewing the wing nut and screwing the screw nut. Here, as you can see, we have to unscrew wing nut and screwing the screw nut. And next, for the position, and the next step is you have to make sure the position weight carrier on the weight platform, and then you have to adjust the spring. So as you can see before, the apparatus, it has the spring tension adjuster. So you have to adjust it, and to ensure the distance of 20 millimeter between the nozzle and the target. So between the nozzle and the target, then by first pressing the spring until the target ring touch the nozzle. So you have to do this very careful and slowly. And then you have to move the pointer. So this is the pointer. So you have to move the pointer that is aligned to the weight platform. Okay. After that, you have to release the spring. So before this, you have to press the spring, and then you have to release the spring and adjust the spring tension adjuster to ensure the distance between the weight platform and the pointer is 20 millimeters. So when you take the reading, you have to make sure that your eyes is perpendicular to the reading to avoid the parallax error, and you can get the accurate result. And then you have to record the value as H. See, you have to measure it first. And then you have to move the pointer. This is the pointer, and align to the weight platform that is floating in mid position. And then you have to record in the table. After that, you have to turn on the pump. So this is the pump. You have to turn on and establish the water flow by steadily open the flash control valve. So this is the control valve until it fully open. So you have to do it slowly like this. As you can see, the flow is low velocity and is high velocity, and the water flow is high. And then the next step is to the target beam will now be deflected by impact of that 8 weight onto the weight carrier until the weight platform is again floating in main position weight platform aligned with pointer. So at this place it has the weight, and then you have to take one and place onto the weight platform. So you have to take one by one and adjust the weight. And after that, you have to measure and record the flow rate together with the corresponding value of the weight and on the weight carrier. Observe the form of the deflected jet and not its shape. So this is before this, it not close, so you have to take and close it first. After that, you have to take the stopwatch, and then you have to measure the flow rate, and like this. And you have to make sure your eyes is perpendicular. Then take the reading, and then you have to measure and record the flow rate on the table given. After that, you have to reduce the weight on the weight carrier in step and maintain balance of weight platform by regulating the flow rate for a few steps, each time recording the value of flow rate and weight on the weight carrier. So as you can see, the weight that we put just now, we have to take off and put it back at here, and then we have to close the valve slowly, and then we have to record the flow rate and the time. After that, we have to fill in the table given. After that, we have to close the control valve and switch off the pump. So this is the control valve, and inside the control valve has the switch of the pumps like this. You have to switch off the pump. And lastly, you have to repeat the experiment with different target bin and the nozzle. So that's all for the procedure, and we proceed to the next, which is the result and analysis. So this is the table for all the type of the nozzle, for nozzle size and the target, and it also provide the table and graph. So this is for the table 2 and table 3, table 4, table 5, table 6, 7, 8, and the last experiment is the nozzle size, which is 8 mm target rate 30 degree nozzle area, which is 1.9635 times 10 power of negative 5 meter per meter square. And I will show you how to do the table and the graph by using the Excel. Okay, now I will show you how to do the graph and the table by using the Excel. For the calculation, I will show you how I calculate the calculation to insert into the table for the this table, and let's see how to do the calculation. Okay, we proceed to the discussion. So let's see. The first question is, example, explain the graph obtained from the experiment, including the reason why graph is such in form. So most of the graph follow a similar pattern in which the theoretical force increase linearly with the experimental force as both value increase with time, and a few graphs show some irregularities in the experiment values due to error in the experiment. And the next question is, discuss why it is crucial to make sure the placement of the nozzle head is at the center under the bed, because it want to ensure that the water distribution, volumetric flow rate, and the fluid pressure along the apparatus. And the next is discuss how an additional weight onto the weight carrier would affect the force exerted onto the target bin when a water stream strikes So the answer is the weight counterbalance force striking water by applying normal force, which is less time gravitational acceleration, thus usually producing an equilibrium in which an apparatus does not burst open. And next question is explain what the type of error. So the flow error might cause the error between this value, which is the lack of accuracy in the apparatus is one of them, and then it will affect the experimental value to differ from the theoretical value, and then other than that, the plane position may not have a precise inflection as the plane angle is not situated legitimately at 90 degrees, 120 degrees or 180 degrees. And the other reason is could be assumption and limitation, which we will make to derive the equation. And lastly, the error is come from the human, it is the accuracy due to human natural limitation. So we have to take the recording for several times and then take the average. And then the application of the moment equation discuss why we can usually disregard the atmospheric pressure and work with gauge pressure only. So by applying the moment equation, can disregard the atmospheric pressure and work with gauge pressure only, since the atmospheric pressure acts in all directions, it is cancelled out in every direction. And the last question is as an application of this study, discussed in terms of momentum and airflow how a helicopter can hover. So this is the explanation about the airflow helicopter, why helicopter can hover. Now we proceed to the conclusion. So the conclusion for this experiment is, in conclusion, the calculated force is correlative with the measured force. Both of the forces will have a directly proportional relation. The theoretical and the calculated force should be the same as the measured force. However, this cannot be achieved experimentally due to the errors made during the experiment. So from this experiment, the airflow rate for the hemisphere is found to be the lowest and thus require a longer time for the volumetric tank to rise. Okay, we go to the recommendation. So the recommendation for this experiment is to keep a few assumptions in mind. So firstly, the effect of gravity on the water jet is neglected. The velocity of the water jet will decrease as it leaves the nozzle and before it collides with the target surface. And the decrease in the velocity due to the acceleration due to gravity will cause more mass to produce the effect of the same flow rate. And the other assumption is that the contact between water molecule and the target surface is frictionless, and the movement of water along the target surface is not frictionless. The energy, which is the energy is lost in the form of heat. And moreover, the assumption of elastic collision between water molecule and walls also caused the error of the experiment. The collision between a water molecule and target surface is not completely elastic, and therefore some of energy transformed into heat energy due to friction. The application for impact of death, the engineer and designer use the momentum equation to accurately calculate the force by moving between as on a solid body. For example, in hydropower plants, turbines are utilized to generate electricity. The turbine rotates due to force exerted by one or more water jet directed tangentially onto the turbine's wing or backwards. The impact of water on the wing generates a torque on the wheel, causing it to rotate and generate electricity. And that's all for the experiment 3, which is impact of death. And that's all from me. Thank you.